Thank you very much. Thanks a lot for the introduction. I'm happy to be here. You're most likely tired of hearing this, but let me share my screen. I have something to show you because today's talk will be about Scalable AI. The presentation I brought you is basically divided in 6 chapters, so to say. The first one is basically the introduction and motivation. So how did I come up with this topic? Why do I think it's important? And yeah, just the general gist of it. Second one will be the first technical differences between software and machine learning application, basically the life cycles. Next topic will be basically about handling data. You will notice it's a big part of machine learning, this data stuff, and that's why a big portion of the talk will also be about data. We finally arrive at the point of just discussing the challenges that there are in scaling and how to approach these challenges. These are just suggestions from my side and what I found out so far, what works for me, and a wrap up and hopefully a discussion in the end. Yeah. How did I come? Who am I? First things first. I mean, Nikolaj just already said everything there is to say about me. I'm working as a senior consultant for MHP. I'm do know a bit about technical stuff. I've worked with NLP and NLU projects. I did recommendation engines, and the topic I'm currently focused on is basically how to scale machine learning prototypes. So basically, not only develop to the proof of concepts, but also how to transition them into usable projects. You can find me either on LinkedIn via the link, or if you're technically adept, you can just take a quick screenshot. Otherwise, you got the link already in the invitation. And yeah, let's start out. The first things I want to talk about is basically just how did I come up with the topic and why I think it's important and relevant in the end. I mean, most of you will most likely be familiar with machine learning, but I'd like to give you some facts and figures and why it is important. As you can see on the left, this is some statistics which are, I think, from last year, if I'm not mistaken, latest 2018. As you can see, across all possible domains, we already see machine learning as utilized, especially in those that are more or less novel. So to say, researching novelty. So for example, research and development is, I mean, almost 3/4 of it are already using machine learning. Also, business intelligence or operations are greatly using it already. Also, marketing and sales. There are, however, still a few fields that are either not utilizing it, or rather not even willing to utilize machine learning. And this is, for example, finance. The only explanation I have currently why finance is rather not so much interested in using machine learning might be in the fact that they actually have methods already in place that greatly help them already implement some stuff, namely statistical models, for example, for time series analysis or something like that. What's more, when we basically go away from the domains and concentrate on the thing about machine learning that is mostly in the focus for everyone, that is models, you will notice that there is a distinct difference between different organizations or teams and how they work with machine learning. And for me, the most prominent point to distinguish these teams from each other was the time it took one team to basically deploy their machine learning models. As you can see from this chart, a rather small percentage even managed to deploy their models in 1 to 7 days. That means it took them less than a week. And I have to emphasize this, less than a week to deploy a model. The overall majority, and this is 50% of it, it takes them more than a week and up to 3 months to basically deploy one model. And you can imagine what kind of host of problem this brings with it. If you take 1 month, let's say, to deploy a model, your model is obsolete the moment it comes into production. And this is a huge problem. And even if you want to update your model, it takes at least that long. So that's the reason why I thought about this topic and how basically I want to address it, because I think this is a huge challenge and there got to be some ways to face them. And the first topic I want to cover regarding this overall complex is the difference in life cycles. So just the question, why is machine learning, why do we have to deploy the models, why it takes so long, and what's the difference between, let's say, software applications as we know them? As you can see on the left, just general software applications have a distinct life cycle, which is characterized by having 4 distinct phases. The first one is a design phase. You basically gather your requirements for the model, you gather your user experience you want to convey. You go over in the next phase, which is the implementation. So you basically take the designs, hopefully, and then basically create the software, the piece of software out of it. You go over, you deploy it, and then you have a phase of monitoring it. Of course, this is also a life cycle, meaning you can begin from the beginning. So you just take your application that you already have, and then you begin again anew with the design phase, and then implement it, deploy it, monitor it, and so on and so forth. Difference between the software application and a machine learning application is that machine learning basically begins with the need to optimize something. This is the top left corner, as you can see. You have the need or the idea to optimize something. It can start with just some general ideas. So for example, you have the need to optimize your identification of items in your warehouse, for example. You have some data for it, and then you start with the experiments. So you begin your goal and you try out stuff to basically get your results. These experiments lead most likely to models which then need to be trained. You have a phase where you validate your models on some unseen data, and then you begin with the model freeze, meaning that the training is stopped, the validation is stopped, the model is frozen in time, meaning that there is no change to the model. I know this is pretty generic. There are some exceptions to this, but just assume that most models are frozen. Then we have a phase of deployment, also on monitoring, and then we begin anew. So basically we have the optimization again and the experiments and so on and so forth. And as you can see, there are quite some different steps from this classical software application that make it basically more challenging to scale machine learning models. What's more is the topic of data. Not only the application itself, but also the data that is fed to an application is extremely important in it. And to basically quantify or assess how organization teams deal with data, there is the data maturity level. This level is basically built up, as you can see, as a pyramid from the ground up to the top. Lowest levels meaning that they have the most challenges with data, and highest level means that they gain the most value out of data. This model is basically divided on 2 dimensions, which is important to distinguish because the one is technology and the other is organizational culture or team culture, just to say. And I think that is you need just to differentiate between those two, because even if you have the best tools, you might lack in some cultural things which make it pretty difficult for you to basically deal with data. So just to give you a broad idea how this model is built up and how the different levels of the model are considered. The first thing, or basically the ground level for organizations, is called data blind organizations. These basically have absolutely nothing when it comes to technology in regard to data. So no databases, no data tools. And of course, since you don't have any tools or data, you also have no data analysis. This phase is described on a cultural level by having absolutely no data strategy. Of course, you have silo thinking, meaning that you have no exchange between the departments, and this is just the reason for the lack of need for analysis. So you don't care about data. You just go, you do your stuff, and you're basically very much blind to data. The next level above it is called data reactive. Technology-wise, you have organizations that have basically very simple and limited databases, be it Microsoft Access or just a very small Oracle database, something like that, and also very simple data tools. So for example, Excel with macros. And this leads basically to teams and organizations having also very simple data analysis. So anything that is just like a look and feel kind of stuff that has no hard facts. On the culture side, you have the organization is basically described by having the data only for their immediate business needs. So I think you're pretty familiar with this kind of stuff. So basically only have the data that is exactly needed for the one thing you have right now doing, and you basically don't care about anything else. You still have big silos because, quite frankly, why should you exchange any data or any knowledge between different departments if you just have your single goal focused? And that's the kind of thinking that is on this level. And also, this leads to basically having independent data analysis. So you exchange nothing between each other. That's, yeah, kind of describe in this. The next level is basically called the data active level. Technology-wise, you begin kind of having different levels of data technology. So you have data lakes or data warehouses. I won't go into any details on the technologies. It's just a broad description. You also have ETL, so meaning extraction, transformation, loading tools to basically feed these databases. And you finally begin using complex analysis to basically work with your data. In my personal opinion, this is kind of the level where you finally begin thinking about machine learning, where you finally think about having complex analysis on your data and using, for example, data science methods to analyze your data. Cultural-wise, this level of data active is characterized by having a data strategy. So now you basically open up your eyes to the world of data and you start thinking about the ways you can utilize the data, how you can organize it, how you can basically extract the value out of it apart from your immediate business needs. This leads also to the point that you also start thinking about exchanging data between different departments. This, in turn, allows you to have analysis that go over one department and basically aggregate it together, meaning you can get results that are not only focused on one single department or one single team, but rather are giving the meaning or the value can be extracted from overall a synthesis of different teams and different data. The second to last level is called data proactive. Technology-wise, not much changes, to be frank. So you still got some kind of data warehouse or some kind of data lake that you have inside the organization, but you start up automating way more stuff. So you don't only have ETL tools, but whole pipelines that allow you to basically connect new data sources and transform them in a way that you can use them with the data you already have. So you kind of have at least some kind of common storage medium, even if you don't have a common storage format. And this is the point where machine learning also becomes much more prominent because you start utilizing, for example, predictive analytics over complex analysis. So this is kind of, it gets more sophisticated and more complex. Culture-wise, this level is basically characterized by extending the data strategy to a point where you start gathering data proactively because you start thinking about the future, not only your immediate goals that you have right now, but also the possibilities that data can open up for you in the future. And you also start proactively collecting the data to reach these possible goals. This level is also described by having data knowledge in the department itself. So you don't only have a central data science team, as is probably the most common thing, but you also got some kind of understanding of data inside distinct teams spread all over the company, which I think is a very, very important part of basically bringing data knowledge to all employees. And also, culture-wise, I think this is a super important point, is that you basically start sharing your knowledge and sharing your results. So basically got people that talk to each other, and this in turn fosters the possibility to basically exchange and gather new insights. The top of this model is described by, or rather it's called data-driven organizations or teams. It's described on a technology level by having technology-wise still data lakes or data warehouses, but there's also a very strong need to basically have data versioning. So you have also the possibility to see how your data evolved over time and not only how the data is at the current state of time. You have at this point pretty much machine learning or even AI, furthermore, tools and frameworks that you utilize, and you have also very complex analysis. And also the decisions are based on this analysis. So you don't have them basically just for themselves, it's like a self-fulfilling need, but rather you make decisions based on these models or analysis that you make. Culture-wise, this is also reflected by the data being an integral part of your value chain, not only just part of your company, but this is just the most important thing that is driving it. And you also have, as said before, data-driven decision-making at this level. So meaning that you don't only trust your gut feeling and your instincts, but you also have the data to back it up. Just to give you some basic ideas on how I personally think you can advance through the different levels, just to give it a quick overview. Advancing from data blind to data reactive is technology-wise rather, let's say, simple. Not easy, but simple, because this is basically just about having the technology in place. So you might need an IT department and you might need some databases. Culture-wise, I think this transition is characterized by discovering the business needs that you have and how data ties into them, and basically having people that have at least some training on simple analysis. So you basically have some, for example, statistic backgrounds, or some people that had some statistic courses in the university, or just have some very basic understanding on how to work with the data. On the other hand, advancing from data reactive to data active on a technology level, in my opinion, is basically characterized by experimenting with new tools. So basically, if you got one database, you start implementing another one, you start noticing differences. So for example, if you have a relational database, you try something like a non-relational one. You have different kind of vendors that you try out. And you also start basically trying out the analysis for business needs. So you know you got your business goals, you talk to the people about them, and you try to basically have your data teams try to reach these business needs with their analysis. And most likely you'll be using some kind of statistic frameworks to reach this. Culture-wise, advancing from data reactive to data active is characterized by having data linked to the business values. So you basically know how data drives your business value, and you try to have people that have already some kind of knowledge on complex analysis. Another important point for me, and this goes through advancing of all of the cultural levels, is basically thinking about how you can enable your people to collaborate together, because I think this is a huge point that drives, even apart from technology, forward, that you basically have collaboration across all levels. Furthermore, going on from data active to data proactive, technology-wise, since you experimented with tools, you have now the knowledge how to get the right tool for the right jobs. And at this point, you start also utilizing basically automation and pipelines. So you know you got a host of, for example, databases and a host of frameworks, but you also need to think about how you can basically automate them, how to basically deploy them. And this is still just from a purely software perspective. Culture-wise, you basically need to establish the importance of data across the company. So you basically need to show how important data is, need to show the results of positive data projects. You also need to think about how you set up your teams, basically making them interdisciplinary in a way to allow you to bring different departments, different knowledge, different experience together in interdisciplinary teams to reach your goals. And also, I think a very important point is that you foster experimentation and sharing across the whole company on all levels to basically just give you the opportunity to work better with the data. Reaching the last level, or the data-driven level, technology-wise, I think it's a huge important point to have automation and the tool chains established. So not only just having distinct tools to pick from, but rather having some kind of connection between all these tools into a tool chain. In my opinion, you will also inevitably end up with cloud-based applications, because at some kind of point you have very big needs to scale. You have a lot of users, or you have huge need in resources, and this basically is at some kind of point is not possible anymore with on-premise solutions. And at some point, I think you might end up creating your own machine learning frameworks just for the fact that you have so much domain-specific knowledge that standard frameworks just don't cut it. And this can also be some kind of basically extension of existing frameworks, but you still end up creating your own one. Culture-wise, reaching the last level is basically, in my opinion, characterized by having some basic data knowledge across all levels. And I don't mean that you know how to implement some standard deviation methods inside the code, but rather that you know what the standard deviation is, that you know, for example, what a variance is or something like that, and that you have it across all levels. So basically, if the CEO knows how metrics are calculated from the meaning, this is a very important point. And you need to establish that basically data is also one of the value drivers across the organization. So basically data is not only there, it's important and it's driving value. So having crossed this data maturity model, having a broad idea how organizations deal with data overall and how they organize themselves also from a technology standpoint, what exactly are the challenges that arise basically in machine learning, and how do they fit to this kind of data maturity model? I have identified 6 challenges which are not, and this is not a complete list, basically. Sorry, this is not a complete list. This is basically just the 6 most prominent ones, I think, that occurred to me over the time. And the first one I want to talk about is basically model lifecycle management. As we've seen in the presentation already, we do have a more complex model lifecycle inside the machine learning application. And this, of course, is pretty much very complex to handle, because you got frequent changes, you got a frequent need to update, and even if it takes a long time, this is a huge challenge. Tied in with this, tightly coupled, I think, is the point of model deployment. And this is not only focused on one team, but rather on how organization mostly operate is that they have some data science team, they have some development team, and then they have an IT department. And there's constant handovers from one team to the next to the other. So you basically have just a lot of friction, because you constantly pass on your artifacts to the next one. And this basically is the challenge in model deployment, just these constant handovers. Another point, which is also kind of tied to it, is the point of team composition, which is also a huge issue, in my opinion, or rather a huge challenge. The people that create models, or rather the people that actually have a knowledge in creating models are not the ones that are also experienced in developing the software. And these, in turn, might not be the ones experienced in deploying and monitoring or operating software. And as you can see, you just have so much need for specialty, or rather very special needs to inside your skills, that not only that one team of like a single expertise simply can't handle it. So this is just the point with team composition, that you need interdisciplinary teams. Another huge problem, which I think occurs the more complex models get, is the point of model monitoring. How do you basically define the metrics to measure your model performance inside production? And how do you evaluate them? How do you actually measure them, even if you define them? That can also be a huge problem. I think which is also pretty interesting, a challenge, which also is kind of a research topic, is the point of explainability. Humans like to have some kind of, I think, deterministic results. So if you do something twice, you expect the same results twice. And this is where machine learning can basically change your point of view, because sometimes even if you allegedly think that's the same kind of thing you're doing, you might receive different answers. So anyone that has talked to Siri or Alexa, any kind of assistant, might already have made this decision, or rather this experience. And this is the point, basically, how do you make your models explainable? One, to yourself as maintainers, but also to the users in the end. This is a huge point, I think, which is also makes it very much challenging to work with machine learning. And the last challenge is something called concept drift, and this is due to time. You usually create a model with some assumptions at some point in time. You have a fixed amount of data that you put into it, and then you basically freeze it. And the moment it is frozen, the model, it basically is old and the predictive power can only degrade. This is due to the fact that basically the environment a model is used in is constantly changing because it's receiving new data. And the less you update your models, the less basically the predictable power loses, decreases. And having an idea of these 6 challenges, how do they basically tie in with the data maturity model, and how you basically can pinpoint them on this kind of maturity model. I think the first point, and this is basically true across all levels, so basically just the first point, I think, which is one of those that can continue up through the whole organization, is the challenge of team composition, basically. You start out with teams, and if you say that you have very specialized teams, you might go with it for a long way without changing it. But at some point in time, you will arrive at a challenge that can't be basically simply can't be solved by one very specialized teams, and you need to think about how you make up your teams to solve those challenges. Next thing is basically the moment you start utilizing models, in my opinion, is the time you also will have the problem of facing concept drift. So this is also very much true already for organizations that are on a data reactive level. Tied into this, as soon as you got a model, you will also most likely face the problem of having issues with your model deployment. So this is also true for already organizations on data reactive level, because it's not easy. It might be, but you still need to make this experience first. So until you've made it, it's not easy for you. As soon as you got your model deployment, you will most likely face the issue of having to manage your model lifecycle. So how do you exchange models? How do you update them, and so on and so forth? And this occurs from the level of data active, in my opinion, on. As soon as you might have faced this challenge, more sophisticated ones are, in my opinion, concerned with model monitoring. So when is the right point to update your model? How do you measure it? What's the kind of metric? How do you evaluate it? That's all something that is occurring on data proactive level, in my opinion. And the last point is the topic of explainability. I think this is occurring more prominently with models that are more complex. So how do you explain them? How do you explain the results of a model? And this is also something that occurs from a data proactive level on. Now, the big question is, how do you approach these challenges? Well, in my opinion, first, I have basically identified, or rather described, the standard process of what happens when a prototype is developed. And this is basically true across a different kind of domains. And if you get some other experience, please feel free to share it with me. But usually it happens like this. Someone got an idea. You have some data-affine people that know how to handle data and know how to program. So you give them some documents. They do some local programming on the laptops. You get, in the end, an integrated script. So basically, just, for example, a Jupyter notebook. That's what you get. This phase can take anywhere between, I don't know, a hackathon, but also a 3-month phase if it is some very kind of complex model. And as you can see, the development only happens locally. The data is document-based. You absolutely have no interfaces to other systems, meaning the Jupyter notebook, or rather this window, is all you get. The application is most likely only available to the developer, and if you got any idea of change, you will have a high effort to implement those changes. So the first phase is basically, how do you change it? Well, you go on, you take your Jupyter notebook, your integrated script to be more precise, and you try to extract basically what is the processing logic out of it. So for this, you all have a bunch of Python frameworks, which I assume a lot of people of you know already. As soon as you got the processing logic out of it, so basically those components that make your script work, make it smart, so to say, you go on and you build some interfaces to it. You have interfaces, I say, internally. So for example, anything that is concerned with databases. This is, for example, a database API or something like that. But you also have interfaces that go on the outside, be it now to users, so for example, any kind of user interface you build, but also to third-party services. So if you got the need, for example, for some extra information or something. And there are also frameworks to gather this. Going on, you basically need to bring those two big parts together. The processing logic, the interfaces, you combine them into one piece of software that you need to deploy. For this, you also got a host of technologies that you're going to go on with. You can use Docker, or you can not use Docker. You can use a lot of cloud services that are available to you. Basically, what all of this leads to is that your application is now available to non-developers. You also have interfaces to other systems, so you basically are not cut off from the world, but you can basically speak to the world, so to say, on a program level, and your application can now be stabilized. Continuing on from this, I think the next point, and this is just might seem like a big leap, but as soon as you got an application that is working, I think you need to both think about tools and how you collaborate across the organization. And I think an interesting way of doing it would be, for example, the methodology of using DevOps. This one is, DevOps is basically described by having distinct phases that also begin with having a planning phase, building, some kind of continuous integration, a deployment phase, which goes over in the operation phase. And also a very important part is that you always have continuous feedback. It can be on an application level that you monitor it and basically try to change it. But it is also very important that this feedback occurs on a human level. So for example, by talking to your clients and gathering their feedback. How is the application working for you? How are the results? Are those accurate or not? And this is just the point which are described around this model. This is the points of collaboration and communication. You need to build, to have a common goal in place that you follow, and you need your means to measure how you progress on this goal. Everyone needs to be aligned on this goal. And this is basically, for me, the core message of DevOps, that you have collaboration and communication in place to reach a goal across the whole organization. Of course, this is supported by tools, but I think this is only a part of it. A huge part, of course, might be in the phase that you try to automate as much of it, but without the proper mindset, I think it will be, pretty much very difficult to actually allow you to implement some kind of feedback culture if you, if you got no culture of having feedback inside the organization. And basically, what I would like to know is whether or not you got experience with it, because I think it will be an interesting idea to basically combine this machine learning lifecycle with the lifecycle of, let's say, DevOps development. So this phases of planning, building, and continuous integration might be augmented by the phases of the machine learning, optimization, experimentation, modeling, training, validation. There are a lot of tools most likely that you can use for them, but just having the idea that you can basically combine DevOps and this machine learning lifecycle, I think is the interesting part here. Another point, which is super important in my opinion, is having some kind of team diversity implemented. So you don't only have those data science guys that are very good at creating models, but you also have those development guys or girls that are very good at designing this and creating the software. And you also need some people from IT that know how to basically operate those models. And you need to bring all those people inside a single team or multiple teams and let them talk to each other and work together. And another point, in my opinion, is having also very much the life cycle automated. So if you can, for example, automate your experiments by having, for example, defined parameters that you search automatically, having model creation automated, then you can go through these different phases of the machine learning lifecycle way, way faster, meaning that basically experimenting is the goal and having measurable results in a short amount of time with a short amount of, or rather with a low effort for your teams because you got it all automated, is what makes it possible to try out different things, compare them to each other, and have the best results in a low effort way to give the best value. Yeah, I think that's it so far from my talk. What did we hear today? What did we learn today, hopefully? Well, the first thing I talked about is the machine learning lifecycle. So basically, not only having on top of your software application, you also have your machine learning lifecycle, which is also a bit more complex. We talked about the data maturity level with the different levels and how they are basically characterized both on a technology level and a cultural level dimension. And as last point we talked about is basically methodology. So basically the idea of combining DevOps and machine learning to try and solve some of these challenges. Yeah. That's it so far from my talk.